So today we're going to be talking about the paper 2 paper, all right? And well, I guess let's just go through with it lah. Okay, since the exams are over, and I guess you can relax for a while. Well, sort of relax lah. Okay, all right. So first question, diagram 1 shows a student pulling a plastic sheet placed on a table. Okay, and on top of the plastic sheet is a plastic cup that is filled with water. Okay, so you can kind of guess what's going to happen. So what will happen to the plastic cup if that is filled with water when the plastic sheet is pulled slowly? Oh, sorry. When the plastic sheet is pulled slowly, so obviously the first thing one is if you pull it slowly, then the cup will probably fall down. Okay, something similar to that lah. Okay, what will happen to the plastic cup? There are some people that talk about the water, which is very strange because the question asks about the cup and then you go and talk about the water. The cup will fall down and then the water will spill lah. But some of you wrote the water will spill, which doesn't answer the question. The question asks for what happened to the cup. So yeah. And then, of course, if the plastic sheet is pulled quickly, okay, there's a spelling error over here, but it's okay. I guess everyone can answer. Okay, then you say the cup, okay, will stay on the table. Okay, atau yang sewaktu dengannya lah. Okay, it doesn't have to be really exact science. It doesn't have to be really the exact words, but it can be this one. Okay, and then of course the explanation for this, we know that the physics phenomena behind this is inertia. Okay, and when we talk about inertia, we need to make sure that the words tendency is always inside. Okay, kecenderungan. Okay, kecenderungan sesuatu objek untuk mengekalkan dia punya keadaan asalnya. So the tendency, okay, the tendency for the cup, okay, to remain at rest is the key word that I need to see. Okay, to remain at rest or remain at its original position. Okay, yeah, or you can say the cup has a tendency lah. Okay, the cup has a tendency to remain at rest or to remain at its original position. Okay, again, the key word for this is the tendency. Okay, the word tendency, and then either remain at rest or remain in its original position. That is the key word that we want to see. Okay, of course, the explanation is the concept of inertia. All right, so it's very easy 4 marks. Okay, just look and observe and then give the explanation for it. Okay. Oh yes, if you have alternative answers, let's say for example you want to check and see whether you're this one, I would suggest that you wait until I finish marking first. Okay, wait until I finish marking, and then if you want to let's say, yeah, so I answer like this. How come you say cannot? Then you can, we can talk about it lah. Okay, so don't ask anything about alternative answers yet. Wait until I finish marking. But right now, what I want to give you is what are the key things that you should watch out for. Or what are the key words that should be put in, okay, in a good answer lah. Okay, that's what we want. All right, diagram 2 shows forces acting on a bicycle pedal by the cyclist. The cyclist cycles forward with a force of 200 newtons. So there's a force here. It says nothing about the acceleration or the velocity. So kita tengok dulu macam mana. Okay, name the dia R1 and R2. Okay, it is the normal reaction force. Okay, if there's no word reaction, I don't think it's a big problem. I think it's a normal force, it's fine. But a good answer will have the word reaction. Okay, so state the type of the motion if the resistive force is 200 newtons. That means forward is 200 newtons, backwards is 200 newtons. So the type of motion, okay, will be either constant velocity or dia punya kawan baik, which is zero acceleration. Okay, so this would be a good time to recap about this, guys. Type of motion can either be constant velocity and zero acceleration, okay, or increasing velocity and constant acceleration, or decreasing velocity and constant deceleration. Okay, tapi these two, okay, ini dua ni, constant acceleration and constant deceleration, really depends on how the movement is like now. Some things can be increasing velocity, but the acceleration is not constant. Okay, so let's say for example like this, if this is a VT graph, this is increasing velocity. Okay, it's a curve like this. It's increasing velocity, but it's not constant acceleration. Okay, tapi if you want increasing velocity, constant acceleration, the graph will look like this, VT, it will look like this. It will be a straight line graph. Okay, so I want you to take note that if kalau kita cakap pasal increasing velocity bahkan, we have to see whether it is actually a constant acceleration or not. Okay, but time and time again, I always see this lah. Okay, whenever I ask for type of motion, then got some people, the bicycle is moving forward. Okay, wow, okay, everybody can see the bicycle. Obviously, it's going to move forward, like it's not going to move upward, or it's not going to move downwards into the ground. Okay, so a part, okay, sebahagian, a part of answering questions is the skill of acquiring the technique of answering. Okay, this is something that personally I don't like lah. Okay, I do, as a teacher, I feel that you should be able to explain things that you want to, but because we are sitting for exam and we are tied down by exam rules, because the exams determine your future and everything and yada yada. Okay, so we have to acquire the answering technique skills. Okay, it's not enough to know what the answer is. It's also important to know how to write the answer. Okay, so yeah. State what will happen to the motion of the bicycle if the forward force increases uniformly. Okay, so again, either either the velocity increases. Oh no, sorry. If the forward force, sorry. If kalau kita cakap forward force, then there's only one answer. The acceleration will increase uniformly. If you answer the velocity increase, I cannot accept, because this is from Newton's second law. Newton's second law says that the force only affects the acceleration. Of course, it affects the velocity. Okay, but according to Newton's law, F and A are the ones that are related to one another. So if the force increases uniformly, the acceleration will increase uniformly. Okay, if you write, let's say, if you write velocity increase, okay, it does not give a clear picture, because sometimes velocity can increase, but the acceleration doesn't increase. Okay, as I mentioned just now lah. Sometimes you can increase velocity, but it's a constant acceleration. Dia makin cepat pada kadar yang sama. Okay, so an increasing acceleration means itu object bahkan it's moving faster and faster as time goes on. Okay, kalau macam odometer bahkan it's going to go like 10 to 20 and then after that to 40 and then after that to 80. Kalau dia increase uniformly, kalau dia velocity increase and the acceleration is constant, it will be 10, 20, 30, 40, dia akan naik macam ni. Tapi kalau dia tidak, if there is not a constant acceleration is increasing uniformly, then the odometer will go 10 to 20 and then tiba-tiba 40 and then tiba-tiba 80 and then suddenly 160. Okay, so that is a not uniform, that is a not constant acceleration. The acceleration also will increase. Okay, talking about this kind of graph. Okay, so if your answer velocity increase, I will mark you wrong because it is not entirely correct. Okay, this is not a, okay, sorry, this is not like the question B, okay, it's not like there's an alternative answer, tiada. Ini saja jawapannya. Okay, that is the part. Kalau type of motion, bahkan you can say, okay, the bicycle is moving forward, and it's still a type of motion. But in this case, in question C, there is no other acceptable answer except for acceleration increase uniform, because it's asking you a relationship between the force and the acceleration. Why will the cyclist experience serious injury if he falls on the road with hard surface? Okay, so this has to do with big impulsive force. Okay, so this is like a combination of a Form 5 and Form 4 question. Impulsive force actually you learn in Form 4. But this one, the acceleration increase and blah, 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 semua ni kan kita belajar masa di Form 5, Chapter 1. Okay, so it experiences a big impulsive force, okay, because the time of impact, okay, is small. Masa pelanggaran dia kecil, so daya impulsnya adalah besar. These two always comes together. Okay, the gymnast bends her knees when she reaches the ground. A parachutist, somebody that's parachuting, bila dia mau sampai sudah ditanakan, he doesn't land with his feet straight like that lah. Okay, of course he has to bend his knees. So when he's bending his knees, when there's a mattress at the high jump, okay, all those things increase the time of impact to produce a small impulsive force. So it has to work both ways, but these two must always come together. You talk about the time of impact, you must also talk about the impulsive force. You talk about the impulsive force, you must talk about the time of impact. Especially if it is a 2-mark question. Okay, especially if it is a 2-mark question. You must talk about these two together. Okay, sama juga macam ini. Constant velocity and zero acceleration kan. If this is a 2-mark question, you definitely have to mention both. Okay, but because it's a 1-mark, so mana-mana satu akan diterima. So, again part of the answering techniques is all this taking a look at the marks, knowing how many things you have to write. All these things are very important. Okay, we don't teach this in normal classes like masa kau belajar bahkan. But when it comes to exam, these are things that after a while you will hear this again and again balik-balik saya akan tekankan inilah. Okay, and then for those of you that are very stubborn that like refuse to follow these exam rules, by and by you will hear me shout this at your ear. Okay, it's like told you so many times already, but you still don't remember. Okay, it's probably because you're listening to music when I'm talking. All right, number 3. Diagram 3.1 shows a horizontal tube AB, okay, with both of its ends are closed, okay, with rubber stoppers. Okay, the tube is also fixed to 3 vertical tubes, X, Y, and Z. Water is poured into the horizontal tube AB. So draw the diagram 3.1 in your answer paper and mark the water level in the vertical tube X, Y, and Z. So obviously you have to draw this out kan? Okay, if in your answer sheet you didn't draw this out, then I'm going to ask, what is these 3 lines? Okay, it's not going to make any sense to me. The instruction is very clear. Okay, draw the diagram and then mark the water level. So I hope that you guys did this, and the answer will be they will be at the same water level because there's no water flowing in and no water flowing out. Okay, so the physical quantity that is affecting the water level in 3.1 is only the atmospheric pressure. Okay, this is actually 2.2, I think, subtopic 2.2. We talk about liquid pressure, but liquid pressure is not affected by the size of the bekas, the container. Big container, small container, the liquid at the same level, okay, is going to have the same amount of pressure, and that's why the water level, okay, in this tree will remain the same. Okay, all 3 at the same level will give you that 1 mark. All right. Now the Bernoulli tube, diagram. Now you're talking about Bernoulli tube. Okay, so the water flows from uniform speed from A to B. Okay, and it is found that the water level of tube P is at Z here. Okay. Question is, at which vertical tube water will rise the highest? Wow. Okay, so it will obviously rise the highest at P lah. Okay, this is definitely like kind of a giveaway. Okay, remember, more space means velocity is low. Velocity low means pressure is high, so the water will be pushed much higher. Okay, this is Bernoulli's principle. Okay, bigger velocity, smaller pressure. Smaller velocity, bigger pressure in a fluid. Okay, satu benda yang sedang mengalir. Okay, so explain your answer in 3B1. The pressure is the highest. Okay, because of the small velocity. Okay, the marking scheme answer apparently is the difference in pressure is the smallest, which is also okay, I guess. Okay, if you want to answer this also can. But basically, there's all this atmospheric pressure that is pushing this down. Okay, so since over here the pressure is very high and this one is the atmospheric pressure, the difference is very low. Okay, the difference is very small, so the difference in pressure will cause the highest change in this one. Okay, manakala ini ya. Okay, if you're talking about this one, okay, this one will be high velocity, so low pressure. So the atmospheric pressure is going to be able to push the water a lot more down. Okay, manakala in this one, since the pressure is so high, right? Okay, the pressure from the water is going to be able to push against the atmospheric pressure more effectively. Okay, and then this one is always in between, in between P and Q. Okay, all right. So calculate the pressure caused by the water column at point X. Okay, we're going to talk about point X over here, which is right over here. So the pressure, because of the water column, will be pressure is equals to rho GV. Oh, sorry, rho GH. Rho GV is uh, buoyant force. Okay, so the rho will be 1000, okay, as given over here. So 1000 times 9.81 times, hold on, 0.15, but you need to change it to meters. Okay, because this is 0.15 centimeters. Yeah, I know. If you take a look at it, actually it doesn't make sense, right? 0.15 centimeters is so tiny. Oh, well. Yeah. Okay, but what to do lah? Okay, if the question already give like that, we have to follow. So, so our answer will be about 1.475, 1.4715 Pascal. Okay, the one calculate the pressure caused by the water column at point X. Now, yesterday I did all this calculation and then I realized that I gave you the wrong answer. So actually it should be 14.715 Pascal. Right, diagram 4 shows three satellites, K, L, and M, revolving around the Earth in their respective orbits. Sorry. Okay, so this is obviously from chapter 3, gravitation. Okay, so satellite M is a communication satellite, which is also known as a geostationary satellite. State one special characteristic of satellite M. There are various characteristics of geostationary satellite. Okay, I'm just going to give one, but if you have other alternative answers, you are most welcome to give it. Okay, so the period, orbital period is 24 hours. Okay, this is kind of the set geostationary satellite answer. Orbital period is about 24 hours. You can also say it orbits from east to west. Okay, so they must be, it must follow the Earth's rotation, okay, or following Earth's rotation. Okay, so the orbit, okay, is following Earth's rotation. You can say from east to west also, no problem. It is also the orbit is at the geostationary Earth orbit. Okay, GEO, geostationary Earth orbit. Okay, all right. Determine the height of satellite M from the Earth's device. This will come from this very super long and complicated formula, which is found in page 2. Okay, so the formula is not given here. Oh dear, so cruel. Okay. Okay, so the formula is not given here. Wow, how many of you struggle with this question, I wonder. Okay, but it is m equals to 4 pi squared r cubed over t squared, I think. Gt squared. Is that the formula? M 4 pi squared r cubed over gt squared. Okay, correct. Yeah. So g is the gravitational constant. 4 times pi, I'm going to write as pi squared. Okay, and then r is the radius of the Earth. So 6.37 times 36. So the reason why we use this is because they give you the mass of the Earth. Okay, they give you the mass of the Earth, and this R is 6.37 times 10 to the power 6 plus the R. Okay, the height. Okay, H lah. Okay, the height of the satellite from the Earth's surface. Okay, because if you remember that all the R's, okay, in the gravitation chapter, always from center of the Earth to the center of the satellite. Okay, so the radius of the Earth is just a little part of it lah. Okay, so this is the radius of the Earth, and this is m, right? So this is the h. Okay, and this is the radius of the Earth. So the r that we want to count now is all this way. Okay, so that's why we have to put this together as like this lah. Then divide by g, 6.67 times 10 to the power negative 11. And then t is the tempo. Tempo is geostationary. So if it's geostationary, it will be 24 hours. Okay, it will be 24 hours, but you need to change it to seconds. So it's 24 times 60 times 60. Okay. So there are many things to consider lah. Okay, ada banyak benda yang kamu kena pertimbangkan when you're doing gravitation calculation questions. Number one is the R. Okay, remember that the R must always take into account the radius of the Earth plus the distance from the surface of the Earth. Okay, that is the actual R. Jangan juga kamu nampak ini R, bahkan terus, okay, that's the R lah. Okay, full stop. Wah, senangnya hidup saya sebab diorang sudah bagi ini. Yeah, they have given you, but that doesn't mean that, you know, that you must just directly substitute it in lah. Secondly, period must always be in seconds. Okay, except for when you use Kepler's law. Okay, Kepler's law is T1 squared over T2 squared equals to R1 cube over R2 cube. Okay, so in this case, the period can be anything except that if this is in hour, okay, this also must be in hour. Okay, because we call this a ratio formula. So a ratio formula doesn't really care about the units lah. Okay, yang penting the unit is consistent. But when you're using such a formula like this, okay, the mass formula, okay, you have to make sure that all your units are converted into SI unit. Okay, and so this will give you an answer of H equals to 3585691.18 meters. Okay, which is the answer that is given lah. Okay, so it's a long calculation, so I'm not going to waste time by this one, but I want to show you that this formula, yes, it does exist, and yes, sometimes they won't give it to you. Okay, yeah, I know it's very unfortunate. Sometimes they don't give it to you, and that's why you will have to either derive it or you memorize it. Okay. All right, centripetal force is needed for the circular motion of the satellite. Okay, name the force that contributes to the centripetal force. Okay, the force that contributes to the centripetal force obviously is the gravitational force. Okay, so itu yang menarik. That is what creates the orbit lah. Okay, the gravitational force. Okay, and it contributes to the centripetal force. Now, if the gravitational force suddenly disappears, okay, what will happen to the motion, okay, of the satellites? And I think this one we talked about this when we were doing the revision for gravitation. Remember, what if the centripetal force suddenly hilang? Okay, so the satellite will fly off lah. Okay, will fly off. Okay, in a tangent. Okay, respective to their orbit. Orbit at that instant. Okay, the satellite will fly off in a tangent, okay, respective to the orbit at that instant. Now, why is it that these words are important? Respective to their orbit at that instant. Because, okay, let's say this is the Earth, okay, and this is the orbit that they are on. Okay, and this is the object. Now, if let's say the force that is pulling this object suddenly hilang makan, this object is going to fly this way. And so this is a tangent. Okay, this path is a tangent respective to the orbit at this particular instant. Okay? If the object is here, okay, if the object is here and it's, let's say, moving this way, bahkan, where is it going to fly off to? It's going to fly off this way. And it is a different tangent because it is at a different instant. And this time, the time over here and the time over here is two different times. Okay, so it's a good thing that this question comes out lah. Okay, because I think it's a good question. Okay, for us to know what the model answer is. Okay, so it'll be flying off in a tangent, but the tangent they must be respective to the orbit at that particular moment. Okay, if you remember your admats, wow, mau juga admats lah. Okay, how do you count the tangent to a curve? Okay, let's say this is a curve. Okay, the tangent is here, right? Okay, this is a tangent, and it's only a tangent at that particular point. Okay, the coordinate of x and y over here. At that particular point, that's the tangent. And at this particular point, this tangent has its own gradient. At another point, okay, if let's say I use this point, okay, this is another x and y. Okay, this is the tangent. Okay, this is the tangent. The tangent is respective to this point. Okay, and the gradient for this tangent will be different already because we're using a different set of coordinates altogether. Okay, sorry, this is very technical but it's mathematics lah. Okay, if anything okay, if anything especially this chapter, especially in chapter 3 okay, you will find that you cannot separate physics from mathematics lah. You can at form 4, form 5 level, you can actually separate the physics from mathematics. It's still possible to do well in physics without doing well at the mathematics part of it. It's still possible, form 4, form 5. But when you go to form 6, people who are like, wow, syoknya physical form 4, form 5 kan, when they go to form 6, and then they realize, astaga, banyak maths pula. Okay, there's a lot of mathematics actually, okay, that is involved in physics. Okay, so it's important to have, both together lah. They say that physics is the king of the sciences and mathematics is the queen lah. So you cannot separate the king and queen, obviously. And what is chemistry and biology? Not worth talking about lah. Sorry. Okay, so it's just physics and maths are the king and queen. That's all I know. Okay, so I only live to learn about the king and the queen. Who cares about the other two subjects lah? Totally insignificant and irrelevant. Okay, so fly off at a tangent respective to their orbit at that instant is a model answer, which if after you've listened to me ramble on for the past 5 minutes, you still don't understand what I'm talking about, it's okay, all right? Memorize the answer as is, okay, for exam purposes. And then maybe when you have time, like after your SPM is over, you can sit down and think about apa bahasa benarnya ni tangent respective to their orbit at the east. Okay, so yeah, it would be something interesting to to think about. Lah. Okay, this last question is actually a short question, but it's become long because of this one. Okay, if the satellites K and L are at the heights sorry, if satellites K and L are at the heights of 2r and 3r from the Earth's surface, calculate the ratio of the period of satellite K to satellite L. Okay, so this obviously is Kepler's law. Okay, Kepler's third law, which is the formula I showed you over here, T1 squared over T2 squared equals to R1 cube over R2 cube. But now they say that the ketinggian is 2R and 3R. So let's draw it out. Okay, let's draw it out. So K is 2R and L is 3R. Okay, so if we follow this, we need to remember that even though K is 2R and 3R, right, we need to add together with this R. And all the R's. Okay, in every formula in gravitation starts from the center of the Earth or the center of the planet or whatever is in the center of the orbit. Okay, so we are talking about T1 squared over T2 squared equals to 3R cubed over 4R cubed. Okay, because, okay, take a look at this. This K is 2R, right? But there's also a R here. So 2R plus R is 3R. And R plus 3R is 4R. Okay, and that's why I'm writing it like this. 3R cubed over 4R cubed. Okay, so now it comes down to this. We want to find the ratio of the period. Okay, we want to find T1 nisbah T2. But our formula is T1 squared over T2 squared equals to 3R cubed over 4R cubed. Okay, this is where it's like, oh no. Lepas ni saya tidak mau ambil physics sudah sebab dia banyak mathematics. Okay, T1, I'm going to combine these two together, T2 squared. Okay, this one is going to give me 27R cubed over 64R cubed. 2764, am I right? 3 times 3 to the power of 3, correct? 4 to the power of 3 is 64. Okay, R cubed. And then obviously this R cubed kita boleh potong dan potong lah. Okay, totally not a problem. But now we are down with this problem, We want to find the ratio. Tapi so weird by this ratio. Where is this 27? Mana ada punca kuasa 2, 27 makan. Okay, dia ada punca kuasa 2, 27. So what can you do about this? So what you can do is you can split it into if you split okay, 27 and 64, this will be T1 and T2. Okay, and this is where your form 4 admits the law of surds comes into play Okay, so this will actually be T1. Oh no, everybody's going to kill me. Okay, square root of 3 times 3 over, this will be square root of 4 times, T1 over T2. Okay? No, it's not the square root of 4. It's 4 times the square root of 4. Yes, 4 times the square root of 4. Oh, square root of 64 is 8 lah. Okay, fine. Square root of 64 is 8. Okay. Oh yeah lah, actually why am I even thinking about this? Tak payah. Begini sajalah. So the answer, okay, it's a very weird answer, but this is how it is lah. 3 square root 3 over 8. Okay, this is the final answer. Yeah, 3 square root 3 over 8. Okay, all you have to do is just kasi simplify the surd sajalah. Okay, if you just give me square root of 27 over 64, it's definitely incomplete. Okay, because yeah, it's incomplete lah. Yeah, because dia masih lagi boleh dipermudahkan lagi. Okay, so you will have to definitely use this. Okay, so yeah, this is like, we should have done the class at 1 o'clock instead of 1:30. Now I'm so sleepy already. Okay, never mind. Okay, it's just a discussion. Okay, if you don't understand what's happening, you can watch this video a little bit later. Okay, and slowly go through these steps. Okay, but actually, this is a very good question lah. For me lah. Okay, for me as a teacher, if I'm setting a question, this is a very good question to ask. Okay, and I think this is a question from the textbook. Kalau saya tidak silap. Okay, last question for the day lah. Last question for the day. Number 5. I think maybe you do number 5 and number 6 because it's relatively related and quite easy. Okay, 5.1 and 5.2 show a ray of light directed to the surface of the glass block and the surface of the water. Okay, so obviously this has something to do with refraction lah. Okay, so based on diagram 5.1, 5.2, compare the bending of the ray when it enters the glass and the water. Okay, actually both of it is this one, but we find that the bending of the ray, who bends more? Is it the glass or the water? Okay, obviously in the glass lah. So 5.1 is more than 5.2. The bending of the ray in diagram 5.1 is more than the bending of the ray in 5.2. Remember, the nearer you are to normal, okay, the nearer you are to normal, or the lesser, okay, if this is the incident ray, this is supposed to be how it's supposed to go, right? Light travels in a straight line. Okay, let me draw this same one over here. Okay, now you look at this. Look at this angle and look at this angle. Obviously, 5.1 has a bigger bend. Dia lebih terbias. Okay, berbanding dengan 5.2 because the bend is so much bigger. Okay, dia sangat jauh daripada sasaran lah. Okay, so that's why 5.1 is bigger than 5.2. Again, everybody, just to remind you, I'm writing this only as an answer, but in the actual SPM, I insist that you are writing this in full sentence. Okay, compare the angle of refraction in both the glass block and the glass water. In water, 5.1 will be lesser than 5.2 lah. The angle of refraction is here. Okay, sorry, let me mark this in red now. This is the angle of refraction. So 5.1 is definitely less than 5.2. Okay, compare the density of glass and water. This is a no-brainer. Everybody knows this. Okay, the density of glass is bigger than the density of water. Or the density of water is smaller than the density of glass. Okay, that's up to you. So, state the relationship between the density and the bending of the medium. So, the bigger the density, the bigger the bending. Okay, so density bigger, the bending is bigger. And not the other way around. The bigger the bending, the bigger the density, doesn't make sense. And the first one must be the one that is affecting, the cause. The effect must be the second part of the sentence. Okay, if you wrote this terbalik, kalau kamu tulis, semakin besar pembengkokan sinar cahaya, semakin besar ketepatan medium, bahkan ya tidak masuk akal. Okay, so please take note of this. Okay, the phenomena is refraction. Okay, this is quite normal. All right, diagram 5.3 shows man. Okay, I think, if I'm not mistaken, I think I discussed this with you all on how to draw this thing, right? Okay, yet I see some of the most peculiar, the most peculiar ones lah. Okay, so I show you the hack. Okay, but if you don't remember, I'm going to show you the hack again lah. Okay, first of all, you draw the fake fish first. Okay, and let's use the eye lah. Okay, so kita pergi from eye to eye. Okay, so first of all, you draw a straight line from the fake fish to the eye of the guy. Okay, the eye of the guy. I hope you didn't spend too long of a time drawing this guy's face lah. Okay, then after that, you draw a normal line. Okay, where the sempadan of the water and the red color line meet. Okay, then after that, you draw this one. From the place where it meets, you draw a straight line over there. Okay, and so this is where, this is how I want to see this. Okay, so the position of the fish must be away. And then, of course, the second one is I want to see the refraction. The refraction is towards the normal. No, away from the normal, correct, because it's going out. Okay, so this is yeah, this is the thing I want to say. So again, as I said, start with the final position of the fish. Okay, final position of the fish, draw a straight line, and then after that you draw the normal line at the sempadan makan, and then the actual fish, okay, you draw this one. Okay, so this is the one that design ini yang putus-putus. Okay, this is the one that's putus-putus, so that the image forms over there. Okay, and then you explain how the phenomena happens lah. So phenomena is called refraction. Okay, so light travels, okay, from more dense to less dense. Okay, water to air. So it's more dense to less dense. And because it's traveling from more dense to less dense, okay, then you say that the light, okay, bends or refracts away from the normal. Okay, ini mesti sama-sama yang dia datang. Always comes together. Light travels from more dense to less dense. And so the light bends or refracts away from the normal. If you want to make it even more complete, and since this is also a revision session, I should also mention this lah. Okay, the speed of the light ray increases, okay, in the air. Okay. So, light in the water is slower, but light in the air, it's much faster lah. Okay, so as it goes from the air, water into the air, the light speed is going to increase. Okay, and that's why the refraction happens. Okay, you can put all three if you want, but of course, maximum you will only get 2 marks. But generally, if it is a 2-mark question, especially if it's the structure one, these two will be the ones I will look for. Okay, saya mau tengok dia pergi dari mana ke mana. And then secondly, saya mau tengok dia punya sudut biasan, the angle of refraction. Is it bending away from the normal or is it bending towards the normal? Start with that first lah. If this is a 4-mark question in section B or section C, okay, then you will need to talk about the speed of the light ray in the air and in the water. Definitely you will have to talk about that. Okay, but as a starter, let's start with this lah. Make sure that we have this in our minds. Okay? Talk about the change in density, talk about the refraction angle, away from normal, towards normal. Okay, that's what we want to see. Okay, sorry, let's do this one last one, number 6, so that tomorrow I only have to do 7, 8, 9, 10, 11, 5 questions. Okay, so magnets, yada. Galvanometer is this one. So this is obviously electromagnetic induction lah. Okay, what is meant by induced current? Okay, it's current due to, and then not sure if you remember what is the keyword for this. Okay, it's either the change in magnetic field or the cutting of magnetic flux. Okay, it's either the change in the magnetic field or the cutting of the magnetic flux. Either one of these words are fine. Okay, induced current. Okay, electromagnetic induction. Okay, electromagnetic induction, okay, is the production of induced EMF. Okay, yeah, it's production of induced EMF due to the change in magnetic field and cutting of magnetic flux, blah, blah, blah. Okay, so almost the same definitions, cuma kalau electromagnetic induction, kita guna perkataan induced EMF. Okay, but when we're talking about induced current or induced EMF, apa itu? Dia adalah current yang terhasil atau EMF yang terhasil, okay, because of the change in magnetic field or the cutting of the magnetic flux. You don't have to put both, okay, just put one of it is fine. I'm just giving you more options lah. Okay, all right, compare the number of turn of the coils. It's quite simple, okay, 6.1 is less than 6.2. Okay, compare the deflection. Not sure if you can see, but obviously 6.2 will have a bigger deflection because the angle is bigger. Okay, so 6.1 is less than 6.2. So state the relationship between the number of turns and the deflection. So the number of turns bigger, okay, deflection is bigger. Again, it's standard lah. All right. Okay, then state the relationship between the number of turns and the magnitude of the current. Also the same thing lah. Number of turns bigger, magnitude of the current is also bigger. It's directly proportional to one another. Okay, and in case, okay, in case in the future, if they ask, whose law is this? This is Faraday's law. Okay, remember that there are two laws that have to do with electromagnetic induction. One is Faraday's law that talks about the size of the current. How to make the current bigger is Faraday's law. Okay, Lenz's law is how to determine the direction of the current. Okay, that is Lenz's law. You need to differentiate between these two. Okay, two different people came up with two different laws in the same situation because they are answering different questions. Okay, Faraday is how you make the current bigger. Okay, Lenz is how you know the direction of the current. Okay, so I hope this helps. All right, now this is a question. There is somebody and a few buddies in this class that will probably smiling because he or she knows why this question came out. Okay, and we purposely decided that we wanted to put this question in because it is such a good question, okay, that deserves to be mentioned so that nobody can say, wow, so you never teach us this question, suddenly this one come out. Okay, so it's very important. Okay, so diagram 6.3 shows a student using a balance, okay, electronic balance, a magnet and a power supply to determine the force in a wire in a magnetic field. The wire is held between the poles of the magnet. Okay, so there's no current flow. Okay, at this point there's no current flow, and then after there's current flow, okay, look at what happens lah. Okay, now when the switch is turned on, the wire will move upward. Okay, this is very normal. Wire will move upward because the current is flowing this way, and the only rule that explains this is Fleming's left-hand rule. Okay, Fleming's left-hand rule explains this. So north to south, current is here, current is moving this way. Okay, and so the force will go upward. So this one will go upward. Okay, definitely. The question is, what will happen to the reading of the electronic balance if the power supply is switched on? Okay, first of all, let me remind you once again for the don't know how many of time, whenever you see the words what will happen, there are only three possible answers. Either the reading will increase, decrease, or will remain unchanged. Okay, either the reading will increase, either the reading will decrease, or the reading will be unchanged. Now, when we first saw this question, okay, our gut our gut told us that, okay, kalau ini naik bahkan, means the penimbang akan rasa kurang berat. Okay, dia akan rasa kurang berat lah. So our gut instinct was, we say, oh, okay lah, kalau dia rasa kurang berat because the wire is going upwards, right? It's as if you're taking something away from the penimbang. And so the reading will decrease lah. Kan? But actually, what happens is that the reading will increase. Okay? The reading will increase. And this is why. Okay? This is why. Let's stop. Okay. I have to apologize lah. It's a one line. Actually, the answer is very long lah. Okay, but the one line just for 1 mark. Okay, so this is what the answer is. So, the catapult field. When you talk about the catapult field, okay. Okay. So if you remember, if the force is going upwards, right? Okay. If the force is going upwards, the catapult is actually downwards. Okay, if the catapult field is if the reaction force is upwards, the catapult field is downwards. Okay? Okay, so this yang menyebabkan itu wire naik bahkan is what we call the reaction force. Okay, that is what is causing the catapult. Like, kalau kamu tarik elastik bahkan, if you are tariking the elastic, when you let the elastic go, the reaction is going to go that way. But the actual force that is pulling the elastic or the wire is the one that is on the opposite side. Okay, so this is the catapult force that is creating the catapult field. Okay, and the wire naik disebabkan of the reaction. The wire's movement is actually a reaction force. Okay, hold on, 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 hold on. The force upward. Oh, sorry. My mistake. Okay, the reaction force is the other way. Okay, sorry. Catapult force is up here. Okay, this is the reaction force. Okay, and this is according to Newton's third law. Okay, Newton's third law tells us that with every force, there is an equal and opposite reaction. The force is moving upwards. Okay, the catapult force. So because ada benda yang bergerak ke atas bahkan, macam momentum, there is always a opposite force. Like kalau kamu lompat keluar dari boat bahkan, kamu lompat keluar and the boat has to tersentak ke belakang. Bila kamu tembak peluru, bila kamu tembak senapang bahkan, when you shoot the gun, mana ada orang kan bila dia tembak bahkan, terus dia punya tangan pun steady macam tu saja. Tiada, dia mesti tersentak ke belakang. There's always a reaction force behind it. Okay, and so the catapult force, okay, produces a downward reaction force, which is the answer for this. Okay, the catapult force, okay, produces a downward, okay, reaction force. And that downward reaction force is what causes this reading to go more than 108 grams. Okay, an equal and opposite reaction. Okay, sorry. This question is this question is very jahat lah. Okay, but it is such a beautiful question that I'm like, wow, saya mesti bincang ini. It is very, very wonderfully executed lah. Wow. Okay. Our gut instinct is, kalau benda tu naik makan means the wire is descent, so it feels lighter lah. But actually, that's not the case lah. Okay, the force that is created because of the catapult field, okay, results in a downward reaction force. There must be a reaction force downwards. Okay, cuma selama ini we are always so focused. Selama ini we are always so focused on the catapult force, we forget to think about mesti ada downward reaction force. Since chapter 1 in Form 5, we've always been talking about reaction forces. This is one of those cases where that happens. All right, let's continue to question number 7, which is where we left off yesterday. Okay, so table 7 shows two types of pressure cooker and their characteristics. Okay, we are assuming that question 7 is the best choice question. Okay, or the most suitable choice question. And question 8 is the modification question. Okay, modification or design question. Okay, which is similar to section C. Manakala question 7 is similar to section B, the 10-mark question. Okay, similar but not the same. Not the same because it is not as detailed as the 10-mark question, but it requires you to have the same skill sets, which is you take a look at this one, you compare, and then you choose which one is the best. Okay, so after taking a look at pressure cooker A and pressure cooker B, then you have what is meant by heat. Okay, so the standard answer for heat, heat is a form of energy. Okay, the simplest definition for heat lah. Okay, heat is a form of energy. Also a very standard definition that is usually asked, at least in the old syllabus lah. Okay, saya tidak tahu kalau ni syllabus baru ni, quite a lot of things are not in your new syllabus as compared to the old, so they may or may not ask this. Okay, yeah. Okay, maybe I should also mention now, because I see that there are people who are dropping in and dropping out now. So if you find yourself dropping out and you cannot connect back now, okay, I would say, just go and rest lah, okay. I mean, I'm not giving you a license, everybody, to, okay, semua orang boleh keluar dari Google Meet. No, I'm not saying that lah. But if you're dropping out because of the weather and everything, okay, just drop out lah, okay? Doesn't really matter. You can watch this video later on YouTube anyway lah, okay? But of course, having this class live, okay, gives you the opportunity to ask anything or any questions that you have lah. Although usually, you guys don't really like to ask questions. Okay, but let's just take it as it is. All right, so based on table 8, state suitable characteristics of the pressure cooker if it is to be used for boiling meat in a short time. Okay, this is what we want. The purpose of our choice is so that we can boil meat in a short amount of time. Okay, so the specific heat capacity for the period, for the body of the pot, okay, should be low specific heat capacity. You can put it as short as that if you want. Okay, low specific capacity. You can just put low also can. Okay, or small specific heat capacity. Okay, and then the reason will be the heat transfer, okay, will be faster. Or you can also say cook faster. Okay, or the standard answer for low specific heat capacity will be heat up faster. Okay, sorry, the pot, okay, the pot will be able to heat up faster. That's the standard answer, okay, for low specific capacity. Heat up faster, heat up slower. Okay, that's the standard answer. Okay, and likewise, when we talk about that, we talk about the handle of the pot. Okay, handle of the pot, the specific heat capacity must be high specific heat capacity. Okay, so that it can heat up slower. Okay, heat up slower, or heat transfer will be slower. Okay, either one is okay. The standard answer which I usually give to all of you is these two lah: heat up faster and heat up slower. These are the two standard answers for low and high specific heat capacity. Okay. Now, the existence of the safety valve, of course, you need to have a safety valve lah. Okay, have a safety valve. Okay, and I noticed that a lot of you gave this answer, have a safety valve, but you didn't really know how to explain the safety valve's function. Okay, so let's pause a little while and talk about the pressure cooker. Do you know how a pressure cooker works? It's not a normal pot. Okay, a pressure cooker is, there's not, this pressure cooker is not actually complete. There's a lock somewhere, So you put all the food in, okay, then you close it up, and then after that you lock it lah. Okay, you lock it because it follows Gay-Lussac's law, which is pressure law. The higher the pressure, the higher the temperature, the higher the pressure. Okay, when you heat it up, the pressure becomes high, and that pressure is the one that cooks the food. Okay, that's why it's called a pressure cooker. It uses pressure to cook. Okay, but there is a need for a safety valve. Okay, because if the pressure becomes too much, okay, macam kamu, like if you pump too much air into your tires is going to experience such a high pressure until it's going to burst. Right? So the safety valve is there, okay, so that you can release the steam. Okay, or release the excess steam if you want. Okay, to release the excess steam in order to reduce the pressure, especially if it is already cooked. And we do this periodically lah, sekali-sekala bahkan kita buka itu safety valve so that you see all the steam come out. Okay, in normal pots, we don't have this one because dia tidak kena kunci lah. Okay, it is not being locked. So when it is not locked, bahkan the tutup can actually move around and let go of the steam. You know, like if you boil water in a pot, right? Kalau kamu masak Maggi bahkan, you notice that the tutup can actually move one lah because it's not that dia bukanlah ketat betul lah. But in a pressure cooker, the tutup is locked. Okay, so there's no way for the steam to escape. All the steam is, all the steam at high pressure, okay, is stuck inside the pot, and that is being used to cook this one lah. Okay, but once in a while, you need to let go of the steam. Otherwise, there'll be too much steam in there, and it'll be a very high pressure cooker, high pressure pot, which we don't want lah. Because if a pot explodes, it's not a good thing lah. Okay, so so the benefits, macam saya menjual pressure cooker pula kan. So the benefits of pressure cooker is that actually it is cost effective lah. You cook things faster in a shorter amount of time, and you actually use less energy. The only downside to the pressure cooker is that it's actually very expensive lah. More expensive than normal. Yeah. And you don't have to use, of course, you don't have to use, tong gas lah. Especially like you want to cook things like soup, porridge, steamed chicken, steamed fish, all those kind of things. We use pressure cooker, okay, because it's fast. It's fast and it's cost effective. Only downside is that it's expensive. Okay, so we are looking for a pressure cooker that has a high specific capacity for the handle, low specific capacity for the body, and has a safety valve. Obviously, the only one is A lah. Because the body is high, the handle is low, very low. Although this is actually lower, kan? That's why again, just to remind you, we never put the number. Whenever we are asked to compare the number, we just say high and low. Sorry, my mistake. Wait. Low. Sorry. Low specific capacity, high specific capacity for this one. Okay, and then of course it has a safety. So in this section, we only put A, and they only say choose the most suitable. They didn't ask you to give a reason. This is not a section B question. Okay, so be very clear about when you need to give the reason. The one that I scold all of you and I say, whoever give me the lazy answer, I'll make you write 440 times, right? Okay, that one is in section B. You don't do this for section A. Okay, all right. Then question D, the specific capacity of water is 4,200. Okay, the mass is 0.8. The initial temperature is 32. Calculate the heat needed to boil the meat in the water until it reaches boiling point. Okay, so in order to answer this, you need to remember that water's boiling point is 100 degrees Celsius. Okay, something we have been taught now since standard 4. So I hope that I don't remember whether people didn't answer this lah, but I hope for the love of God okay, please remember that water's boiling point, standard boiling point okay, is 100 degrees Celsius. It is not something that you need to understand. It is something that is generally known by all standard 4 kids around the world. So please don't tell me that you don't know. Okay, so the formula that we're going to use, Q equals to MC delta theta. So M is 0.8, C is 4,200, and our delta theta will be 100 minus 32. Okay, we want to change from 32 degrees Celsius to 100 degrees Celsius. And this will give us 228,480 joules. I think so. 228,480 joules, yeah. Okay, 228,480 joules. Okay, it's a very simple 2-mark question. Ganti dengan betul 1 markah, jawapan betul dengan unit, okay, adalah 1 markah. 228,480 only will not give you the full marks. All right. Question number 8 is talking about semiconductors. Okay, and so we spent quite a long time talking about the semiconductors. So the area labeled J is known as the depletion layer. Okay, not the junction voltage. Junction voltage is the voltage required for it to cross over. Okay, but the depletion layer, kawasan itu bernama the depletion layer, lapisan susutan. Okay, in BM. lapisan susutan. Okay, that's what it is called in BM. So, yang diperlukan untuk electrons to cross over from one side of the depletion layer to the other side of the depletion layer. Macam satu gaung lah bahkan. Okay, that voltage is known as the junction voltage. Okay. All right, 8.2.1 shows this is this. 8.2.2 shows the wave pattern. Okay, so let's take a look at this. All right, so this is a half wave rectification circuit. Okay, half wave rectification circuit. So explain the wave pattern. Okay, and since it is 2 marks, okay, since it is 2 marks, so you talk about, so definitely the first mark talks about macam mana forward bias, the second mark talks about macam mana reverse bias. Okay, that's it lah. Okay, essentially that's it. Okay, let me give you the sample answer. So it would be, let me write it full here lah. Okay, I guess we can start with, I guess we can start with diodes allow current to flow in one direction. Okay, I'm quite surprised. Why is it 2 marks? Usually it should be 3 marks. Because ini mesti kena cakap ini. The function of the diode is to allow current to flow in one direction. The first one. Okay, and then the second mark will be, okay, in the first half cycle. Okay, first half cycle. Okay, so this is the first half, second half lah. Ini first half. Okay, first half. This is the second half. So in the first half cycle, okay, the diode is forward biased. The diode is forward biased and the current can flow. And the current flows. And then the next one is in the second half cycle, okay, the diode, diode is reverse bias. And the diode is reverse bias and current cannot flow. Okay, so explanation is simple, but again lah, okay, the diode, apa ini? Okay. The diode is reversed bias and the current cannot flow. Okay, so this is how I will put it. It's quite surprising though. Why is it only 2 marks? It should be 3 because it needs to be mentioned. This one needs to be mentioned. Diodes allow current to flow in one direction. Okay, but I guess maybe the peruntukan markah can only require it for it to be 2 lah. Anyway, if you give all 3 points, you will get 2 marks lah. If you give point number 2 and point number 3 only, okay, you will get the 2 full marks. Okay, but if you give point number 1 and point number 2 only, I will also give you 2 full marks lah. So there are 3 max 2 macam. Let me check the scheme. Yeah, 3 max 2. Okay, so we just leave it at that lah. Okay, but the same thing, whenever you're discussing about diodes, okay, always have forward bias, reverse bias in mind. Okay, that's usually this one. All right, diagram 8.3 state the modifications that can be done to the circuit, okay, so that the charger can produce a steady output direct current, which is what we want, steady output direct current. So the number of diodes so you want to change the circuit in this one. You want to change this circuit. Okay, steady output current means you need more diodes. Okay, more diodes, or if you know the full wave rectification circuit, you know that you need 4 diodes. Okay, 4 diodes lah. Okay, and then the reason will be to produce full wave rectification. Okay, to produce full wave rectification. Okay, then the material of the connection wire This is a very standard one, cuprum. Okay, and then the reason will be low resistance lah. This is the standard one lah. Okay, cuprum or constantan, I guess. Definitely not tungsten and what's the other one? Definitely not tungsten and something else. Cuprum and constantan. Nichrome and tungsten. Yeah, definitely not nichrome and tungsten because those are high resistance. So we want cuprum, constantan for connection wires. Usually it's copper. Okay, sorry, copper wires. Okay, copper wires is usually wires of low resistance. Okay, and then additional components. This one requires you to remember. Okay, and I think I discussed this in another question on another day. Remember that if there is a resistor over here, okay, and then you have all these diodes over here, in order to flatten it, we want to have a capacitor. Okay, so we add the capacitor, and the function of the capacitor is to smoothen the current. Okay, to smoothen the current, or to smooth the current also can. Okay, so this is a little bit like the transformer question lah. It's either you know or you don't know. It's either you get it right or you don't. You just don't know lah. Okay, you have to remember that the capacitor functions to make the current smoother, so that it will have a steady output. Okay, direct current in one direction only. All right, question 9. This is the best choice, this one. So what is meant by the critical angle? This is from the topic of light. Okay, this is from the topic of light, chapter 6 from 4. I just want to remind you that question 9 and question 10, there is a choice in these two questions. Okay, but one thing that was stressed to all of us when we were attending the course is that it is not necessarily satu soalan dari tingkatan 4, satu soalan dari tingkatan 5. Okay, it can be both questions from 4 or both questions are from form 5. Okay, so you don't take any chances lah. Okay, don't say, okay, I will only study everything in form 4 because the essay question, one form 4, one form 5. No, not necessarily. What if both of the questions come out from form 5? Okay, habis lah kamu kan. So just to take note of this lah. All right, so table 9 shows 5 materials A, B, C, D, E chosen to make fiber optics. Okay, so you have different critical angles, you have different strengths, different stiffness, different diameters. So the first question is, what is meant by the critical angle? Okay, so the critical angle is the incident angle which I think results, okay, which causes a 90-degree angle of refraction. Okay, 90-degree angle of refraction. Now, just to remind you, okay, incident angle is this. If the incident angle is the critical angle, the refraction will be 90 degrees. Okay, ngam critical angle. More than critical angle, total internal reflection. Less than critical angle is just refraction biasa-biasa. Okay, refraction biasa-biasa. And it will go away from the normal. Okay, explain the principle of fiber optics. Okay, this is probably the reason why a lot of people didn't answer this question. I think like a big majority answered this question instead. And everybody avoided this because they didn't know how to explain the principle of fiber optics. Okay, so let's get down to it. Okay, let's get down to it. Sorry. Okay, so fiber optics. So the first point is fiber optics consist of two types of glass. Okay, two types of glass. Okay, the two types of glass, and it's different in terms of density. Okay, the inner glass is denser than, so dia macam dua lapis kaca, okay, yang berlapisan lah. Okay, so the inner glass is more dense than the outer glass. Okay, so a fiber optic is like this. Is like this. Yeah. Lah. Something like this lah. Okay, so when light travels, okay, so this is the inner glass, and then this is the outer. Okay, dan dia adalah macam, dia macam tali tangsi lah, dia bukan di tengah-tengah adalah udara atau tiada. It's just pure glass. Okay, so this is a very thick layer of glass here, and this is a very thin layer of outer glass lah. Okay, so when light travels, it is traveling from more dense to less dense. Okay, which is the first rule of total internal reflection. And it must be angled at an angle that is more than the critical. Okay, sorry, I'm going too fast already. Let me go. Sorry, point number 3. Okay, so the ray of light enters from one end into the inner glass. Okay, so the ray of light enters into the inner glass. Okay, it will be shined towards the inner glass. Okay, and then as it goes into the inner glass, bila dia sampai di sempadan outer glass, okay, okay, I don't have enough space for the 4th point, but I'm going to write it up here lah. Okay, so the 4th point, okay, as it approaches the outer glass at an angle that is bigger than the critical angle, it will be totally internally reflected. Okay, the main point that needs to be mentioned is that the angle is, sorry, hold on. The main point that needs to be said is that the angle, okay, is bigger than the critical angle. Itu mesti kena sebut. Otherwise, it won't be totally internally reflected. Okay, so when it approaches the outer glass, it's going to approach it at a critical angle, at a bigger than critical angle of incidence. So dia akan totally internally reflected. Okay, so that will be the 4th point lah. So 2 types of glass. There's the inner glass and the outer glass, and the inner glass is more dense than outer glass because that's the first condition for total internal reflection. Mesti dia travel they want to travel okay, from a more dense to a less dense situation. Okay, and in the more dense, the angle of incidence must be bigger than the critical angle. Then it will be totally internally reflected. Okay, so when it is reflected over here, also bigger than critical angle. So reflect again. Also bigger than critical angle. So reflect again. Okay, and this reflection happens very fast. Dia berlaku sangat laju. Actually, there's a 5th point, and I'm going to give you the 5th point as soon as I can find the space to write. Sorry. Okay, 5th point. So the 5th point, okay, this process continues. Okay, this process continues with the reflected light ray. Okay, and okay, so we want to talk about fiber optics, bahkan. One of the purposes of fiber optics is to transfer information at a very fast rate lah. Okay, but doesn't matter lah. Okay, this process continues with the reflected light ray, and the light ray, okay, travels in the fiber optic. Okay, it will travel because it's continually, totally internally reflected. It will travel inside the fiber optic. It won't be able to go out of the fiber optic. Okay, and this happens very fast. Okay, that's why that's why we can have things like Google Meet today lah. Okay, because of the technology of fiber optics. When you watch Netflix on your TV or your this one, when you're streaming content, when you're playing this, right, you're doing this because of the fiber optic cables. Okay, the information is being sent to us at a very fast speed, and technology these days is finding ways for the information to be sent to us even faster. Okay, total internal reflection is already fast enough. We want to make it even faster. Okay, sebab itulah kan manusia ni tidak pandai puas hati. Not fast enough. Everything is not fast enough. Kan? Tapi kalau kita macam mana? Oh, syukur saya sudah lulus fizik. Itu saja. Okay, no, 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 no. Don't be satisfied. Okay, never be satisfied until it is the end. Okay, it's always good to work towards something higher. It gives us a sense of purpose. Okay, tas kira lagi pagi ni. Alright, question number 3. You are assigned to choose a material that is the most suitable, okay, to be used as fiber optics. Okay, examine this one and determine this one, this one, this one. Okay, so we want the critical angle to be small. Okay, definitely to be a small critical angle. So we're talking about this small critical angle. Because if the critical angle is smaller, the total, I'm going to write the reason here. Okay, so I'm not going to make the table. The reasons are tulis di sini terus. Total internal reflection, okay, happens easily. Or lebih senang berlaku lah. Okay, total internal reflection lebih senang berlaku kalau dia punya sudut genting adalah kecil. You don't have to make it, such a big angle. We don't want to. Okay. The strength of the fiber optic should be high. Okay, we want high strength so that it doesn't break easily. These are standard answers lah. Strength high means doesn't break easily, last longer. All this can. Okay. Shall I write this here? Doesn't. Okay, break easily. Okay, kesian lah kan. Whoever is watching this is like, oh no, sudahlah Sir Marcus punya tulisan ni buruk. Mau lagi dia tulis mengasih tindih-tindih. Okay, stiffness. Do we want the stiffness to be high or do you want the stiffness to be low? Okay, we want the stiffness to be low. Okay, yeah. So this is presenting a problem to us, right? Okay, don't worry. Okay, so we want the stiffness to be low. Dia punya ketegaran okay, dia mesti low, because if the stiffness is high, kalau kamu punya wire bahkan adalah sekeras kayu bahkan, sikit saja dia patah sudah. Okay, so it does not easily break. Okay, if the stiffness is higher, it's going to very easily to break. Another answer that can be acceptable is can bend easily. Okay, dia boleh senang bengkok without, dia mudah lentur lah. I think the word is lentur. Okay, dia mudah lentur, so dia kurang tegar. Okay, and then of course the last one we done, do we want it to be a thick wire or a thin wire? Of course we want it to be a thin wire lah. Okay, we want it to be a thin wire simply because it doesn't take up too much space. Okay, so this one will be does not take up too much space. A lot of people seem to think that you need to have a big diameter wire so that it can travel, so that more information can travel, more light can travel. But you need to know, fiber optics is not just used for internet cables. It's also used in this medical technology we call endoscopy. Okay, do you guys know what is endoscopy? Endoscopy is when they stick something, it's so terrible, either through your nose or through your butt. Okay, so they poke a hole inside your side here and then they put a wire into this one. And then at the end there's a camera, and the camera is attached to the computer outside. So you can see what's happening inside your gut lah. Okay, dalam kamu punya usus. Tidak payah sudah kamu kasih, belah kamu punya usus untuk melihat apa yang salah dengan usus. Okay, so endoscopy is one of those technologies which use fiber optics. But there are a couple of ways that they can put it in, either through your nose or through your mouth or through your butthole, or they make a cut at the side here, depending on where they want to see lah. Kalau diorang mau tengok macam trachea, if they want to see your lungs, or if they want to see, this part, then of course they'll put it through your nose lah. Kan, kalau diorang mau tengok kamu punya usus besar, obviously it'll be through your butt. Okay, they will put the endoscope inside your butt lah. So, you know, but generally endoscopy most people use for gastro lah, okay, for usus lah, okay, untuk mencek kenapa kamu punya, why do you feel so bloated, why do you feel dizzy, yeah, okay, things like that lah. Yeah, who's saying what lah? Oh yes, colonoscopy, yes, colonoscopy is using the endoscope lah. Okay, so anyway, yeah, so that's why it has to be thin. Imagine if you put such a thick endoscope in your butt, it's not a very exciting feeling lah. Okay, I don't know how many of you have ever had colonoscopy. It's not fun. Okay, sorry, I've never had colonoscopy, but I've heard from friends lah. I said no, it's not fun. A lot of people are like, ooh, sioknya, tapi tidak. All right. Question number, this question, okay, this question is the calculation question. I'm going to delete all this. All right. So, diagram 9 shows a glass prism A, B, C, D, and the ray paths that pass through the prism. Okay, so we find that over here, it is being totally internally reflected. Okay, so what is the critical angle of the glass in the prism? Okay, so the critical angle will be this one. If let's say I draw a 90-degree normal line, this is the critical angle. This is what I want to find. So if you take a look at this triangle, okay, you can actually count this angle already lah, kan? So this will be 180 minus 109, which will give you 71. And this will give you 180 minus 60 minus 71, this will give you 49. So if this is 49, okay, you know how much is this already lah. This will be 90 minus 49, which will give you 41 degrees. Okay, so for me, if you just give the answer in full, and I see at least the 49 or the 47 or the 71, okay, I will give you the full mark. Okay, calculate the refractive index. This is n equals to 1 over sine c. Okay, so 1 over sine 41. Okay, and this will give you the answer of 1.524. Okay, so 1 mark here, 1 mark here. Give one example that uses the concept as optical fiber. Okay, so you can have endoscope, you can have binoculars, prism binoculars. Okay, because there are two types of binoculars, which is a mirror binocular or prism binocular. Okay, another one is periscope, also prism periscope. Okay, because mirror periscope only uses reflection, doesn't use total internal reflection. Okay, yeah, so all these are possible examples that you can use. I'm sure there are more, but these are the answers given in the scheme lah. Okay, but usually they will write there lah, okay, accept any suitable answer. As long as it makes sense lah, don't say microwave oven lah, itu tiada kaitan dengan optical fiber, my goodness, jangan. Okay, question number 10. Name an apparatus that is used to measure the electric current. This is like the most basic question lah, kan? Okay, obviously it is an ammeter. Okay, I noticed that there are some people who wrote ampere. Okay, guys, okay, people are not tools. Okay, ampere is the name of a person. Dia bukan alat. Okay, ampere is the name of a person that is a unit, okay, of current. Some people wrote ampere, and I'm like, okay, okay, gunakan ampere untuk mengukur arus. Tampar kepala kamu. Okay, by using diagram 10.1 and 10.2, explain why all the bulbs in diagram 10.2 light up with the same brightness and brighter compared to all the bulbs in 10.1. Okay, so this question was addressed in the exam, and actually the question is correct, the diagram is the one that is wrong. 10.2 is definitely brighter than 10.1. Okay, so what we are looking for is number one, okay, in 10.2, the potential difference, okay, across each bulb is the same. Okay, the potential difference of each bulb is the same, okay, and equal to the sum, okay, of voltage. Okay, so there are four batteries over here lah, so we assume it's 6 volts lah. Sini pun 6 volts. So each of these light bulbs has a potential difference of 6 volts. Okay, that is the first point. Okay, the second point, okay, is that the effective resistance, okay, in 10.2 is lower. Okay, dia punya jumlah rintangan adalah lebih rendah because it's 1 over 1 over 1 over 1 over, then you flip it. Okay, so the effective resistance is much lesser. Okay, so then the third one is the current flowing in each bulb in 10.2 is higher. Okay, then in 10.1. Okay, because this sentence already tells us like effective resistance in 10.2 is lower, means 10.1 the effective resistance is higher. Okay, and if the effective resistance is higher, the current flowing in 10.1, okay, is much less. Okay, compared to this one. Okay, that will give you the full 4 marks. I think I'm coming down with sore throat. Wow. Okay, immersion heater used to boil water, yada yada. So we have different characteristics here lah. The mass, the rate of rusting, the type of material, okay, and also how many millitons. Wow, 1 bar. Okay, so everything is given here. Okay, explain the suitability, hence determine which one. Okay, obviously we want a smaller mass. Okay, we want a smaller mass so that it is lighter lah. This usually comes together. Okay, we want to have a smaller mass so that it is lighter or easier to carry. Okay, you don't want to have an immersion heater that is so heavy, that makes your kettle so heavy, difficult to carry lah. Okay, the rate of rusting should be low rate of rusting. Okay, low rate of rusting so that it lasts longer. It doesn't rust easily. These are standard answers. I think if you've answered enough heat questions, you will know this lah. So the low rate of rusting is does not rust easily. Okay, or you can also say last longer lah. Okay, dia tahan lebih lama sebab dia tidak mudah berkarat. Okay. Oh, sorry, cannot. We cannot use last longer. Cikgu He said cannot use last longer, so we have to, sorry, scrap this. Does not rust easily. The other alternative answer is not dangerous to health. Yeah, because rust is not good lah. Wah, easier to carry also tidak dibenarkan. Sorry, lighter saja. We cannot use easier to carry. Okay, skema pemakahan cakap begitu, so kita ikutlah. Alright, next, do we want to use tungsten or iron? Okay, obviously we want to use tungsten lah. Okay, so we use tungsten because tungsten is high resistance. Okay, high resistance or can produce more heat. Okay, that is the standard one. Can produce more heat, high resistance. You can also say high melting point, also no problem. Okay, and then The last one is how many turns of coil? Do you want many turns of coil or few turns of coil? So we want many turns of coil. Okay, this is definitely out lah. Okay, we want many turns of coil. And so now we find that we have a problem lah. Okay, because there is no, tiadalah satu benda yang semua ada, kan? Okay, so if we take a look at this, the only one that fits the bill is actually P. Okay, because out of the four, dia memenuhi tiga. Oh, sorry. The number of turns many, so that this is normal. The many number of turns is also related to high resistance. So this is a conundrum that we find. Sometimes this happens in SPM. Of course, the best picture we want is all four, semua keempat-empat dipenuhi lah kan. That's what we want. All four dipenuhi, like in this case. Oh, ini pun tidak kan sebenarnya. I didn't make a choice. Did I make a choice here? Oh, I did not make a choice. Did I make a choice here? No. Kan macam I didn't make a choice. Okay, in this one, the best will be C. Sorry. Okay, this one, the best will be C, because although the critical angle is pretty high, it's still in the low range. Okay, so only to show you that at times you will not get all the four things circled. Sometimes you may only get three, and you will have to choose which one is the best. Why do I choose C and not D? Because 30.85 is still an acceptable low critical angle. But high stiffness is definitely something we don't want. We definitely don't want high stiffness. So that's why we have to choose C. Okay, but in this one, we have a big problem because P has a high rate of rusting, but it is the only one that fits 3 out of the 4. Okay, so what do you do when you come to questions like this Okay, and I think and we purposely actually said this in order to teach you all something Okay, it's a very bad lesson to teach but well, what to do Okay, sometimes when you make choice you cannot get the 100%. Wow, ni macam life lesson pula kan. Sometimes you want everything to be 100% perfect. Okay, but in reality, life doesn't offer you 100% perfection. Sometimes you are only given 75% and you're asked to choose, you are asked to, just take the 75% as it is. And this is exactly the case where it happens. What are you going to do? Okay, this is a problem, actually. You are saying that you want low rate of rust, but this one has a high rate of rusting. Okay, dia masalah ini sebenarnya. Okay, but you have no choice because the other heaters are even worse. Ini berat, and this is iron. Lagilah tidak boleh. Kan, you definitely don't want iron. Okay, and then this one is berat, high rate of rusting, and the turns are so few. Dia dua saja. So if you have to choose between P and Q, and I suspect that this is becoming a more and more popular question these days Dia tidak bagi full perfect situation, dia bagi 3 out of 4, and then you have to make a better choice. Okay, so you need to make a more informed choice. Okay, and so I would choose P. Okay, the rate of rusting is still, for me, is still boleh di, it can still negotiate masih boleh kena nego-nego tapi tungsten I cannot negotiate. It has to be tungsten. I'm definitely not going to choose iron. Okay, so the cost, not effective cost and then the number of turns must be many. One have no choice. Okay, so I would choose P as my answer. So immersion heater as we were specification of this is used to boil water. Efficiency is 85%. So calculate the electric current, that this one. So this one is just use P equals to V times I. Okay, and when you use P equals to V times I, okay, you will get I equals to 2.083 amps. 2.083? Yeah, 2.083 scan amps Okay, the output power, you need to calculate the input power is 500. Efficiency is 85%. So 85 equals to output over 500 times 100. Okay, the efficiency formula is given in the beginning. Okay, but anyway, so the output power, okay, is equals to 425 watts. Okay, this paper is quite interesting in the sense that the calculation questions are quite easy except for the gravitation one lah. But it is the soalan yang lain-lain ini yang agak mencabar. Okay, so question number 11. So diagram 11.1 and 11.2 show insulated copper wire is wrapped around identical iron nails to form solenoid. Okay, so this is an electromagnet. This is what is going to happen lah. Okay, it's going to form an electromagnet, which is going to tarik the paper clips up lah. Okay, into the nail. So when the switch is pressed, the iron nails become electromagnet and the paper clips are attracted to the iron nails. So what is meant by an electromagnet? An electromagnet is a conductor that produces a magnetic field, okay, when current flows through it. Okay, the key words that I want to see is something that, my goodness, sorry, wait. Okay, produces a magnetic field. Okay, and then current flows through it. This is what I want to see. If you say a wire or a conductor or an object, object maybe not such a good thing, okay, but a conductor is actually also another keyword that usually we want to see, but a lot of people tend to forget the word conductor. Okay, so it's good for us to look at this now. All right, using diagram 11.1, 11.2, compare the number of turns of the coil, number of paper clips attached to the electromagnet, and the reading of the ammeter. Okay, so let's talk about this. Number of turns of the coil, obviously, if you can see, 11.1 and 11.2, 11.1 is less than 11.2. Okay, the number of paper clips, if you take a look, ini saja paper clip yang attracted, this one has a way lot more. So the same thing, 11.1 is less than 11.2. The reading of the ammeter, sini pesungannya, okay, we find that the reading of the ammeter is the same. Okay, I noticed that quite a lot of you wrote 11.1 is smaller than 11.2 or 11.2 is bigger than 11.1. But actually, that's not true. The factor that is not changing over here is the current that is flowing. The changing factor, the manipulated variable, is the number of turns in the coil. Let me zoom in. Okay, just to show you that, tengok, sama, sebenarnya dia adalah sama. Quite a lot of you, okay, put 11.1 is bigger than, less than 11.2, which I'm like, oh, okay. Okay, so don't assume anything. Look at the diagrams really carefully. Okay, then after that, relate the number of turns of coils to the number of paper clips. Okay, so this one is the bigger the number of turns of coils, the bigger the number of paper clips attached. To make a deduction regarding the relationship between the number of turns of the coil and the strength of the electromagnet. So the bigger the number of turns of the coil, the bigger the strength of the electromagnet. Okay, the bigger the number of turns of the coil, the bigger the strength of the electromagnet. Okay, diagram 11.3 shows two aluminum rods connected to two different circuits and hung close to each other. Okay, state what happens to the aluminum rods when both switches are closed. Okay, so each rod over here, okay, is separate. Okay, dia bukan bersambung. But when we turn this on, we know that this is going to become a magnet. Okay, we turn this on, this is also going to become a magnet. Okay, so it is either they are going to attract one another or they're going to repel one another. And the thing that differentiates between the attraction and the rejection is the polarity of the battery. And the polarity of the battery is the one that changes it. So let's take a look at this. So the number one you need to talk about is the two aluminium rods will attract one another. Okay, so mereka akan melekat. Okay, mereka akan melekat. And how do you know this? Okay, so how do you know this? Is we use, sorry, uh, we see, okay, we see that, okay, if let's say the current flows over here, this is the current at positive. Okay, positive, then it's going to flow over here and up here and then back here. In this one, it's going to flow over here, okay, and we find that at the aluminium rods, they are flowing in the same direction. Okay, the current in both aluminium rods are flowing in the same direction. Okay, the current in both aluminium rods will flow in the same direction. So 3, okay, the magnetic field produced by both rods are in opposite directions. Okay, and in bracket, right hand grip rule. Okay, so you think about this. Let's say if you are looking from this point of view, the current is going inwards. Okay? So current is going inwards is X. Current is going inwards is X. If we use the right hand grip rule, current going inwards means the magnetic field is flowing in clockwise direction. Okay, so it'll be this way, this way, this way, and this way, and likewise also with this. Okay, so the region in the center over here, since the magnetic fields are opposite to one another, okay, since they are opposite to one another, this produces a weak magnetic field between the rods. Okay, this produces a weak magnetic field in between the rods, and that's why they are attracted to one another, because the outside will push them in. Okay, and yeah, and so that's the explanation for this. Since they are both flowing in the same direction, when you use the right hand grip rule, they are both going to flow clockwise, but the place where the two magnetic fields meet will macam dia orang kasi cancel one another lah. So over here will be weak magnetic field, okay, weak magnetic field, and the rest of it will be strong. So this one will push these two rods in. The strong will push towards the weak magnetic field side. Okay, diagram 11.4 shows a simple transformer which is not efficient. Okay, so not efficient for various reasons. Now, transformer not efficient, you kind of need to know the four things, the four standard ones. Okay, so using appropriate physics concepts, explain how you would modify the transformer to increase its efficiency based on the type of characteristics and the coiled wire, the type, then the characteristic of the core, the arrangement of the primary and secondary coils. So this one, we've talked about this when we were talking about transformer. I said that, specific modifications will have specific reasons, and we need to make sure that those reasons are the ones that are correct. Okay, so let's talk about the coiled wire first. The type of coiled wire. Okay, type of coiled wire. Of course, you need to answer this in table, but I'm just going to answer this in this one now. So it'll be copper wire. This is very standard lah. Okay, the reason will be low resistance. Okay, this is a standard one. Okay, then the characteristics of the coiled wire. Okay, the characteristics, is it thicker, is it thinner? Usually characteristics, we talk about that lah. Okay, so we use thicker wire. Okay, and the reason will be to reduce the resistance. Okay, notice I'm using the same reasoning for two different characteristics. Okay, so it's okay for us to use this lah. Okay, and then the third one is the type of the core. Okay, so when we talk about core, we know that we need to talk about soft iron core. Lah. Characteristic will be laminated. So the third one will be soft iron core. Now the reason for soft iron core is, as I said before, soft iron core is very set on, okay, easily magnetized and demagnetized. Okay, it's just one of those things that dia memang pasangan. You cannot separate the two of them. When we talk about transformer, we must think about soft iron core. Okay, and then the fourth one, the characteristic of the core is laminated. Okay, laminated core. And the reason for this is, what's the reason for laminated core? Okay, is to reduce eddy current. Okay, again, one of those things that is either you remember or you don't remember. Okay, then the last one is the arrangement of the primary and secondary coils. Okay, so you wind, okay, wind the secondary, okay, on top of the primary. If you terbalikkan this, I don't see a problem with it. You can put the primary on top of the secondary also, totally no problem. But if you put the primary on top of the secondary, okay, then the yang di atas itu kan, dia akan hilang kan. We don't want any. So the reason why we do this, okay, is the reason why we do this is to avoid flux leakage. Okay, so that's why the secondary must be on top of the primary, because if the primary is on top of the secondary, so yang di bawah saja yang akan kena the secondary, yang di atas ini akan terbocor juga kan. Okay, so the primary must be always inside, the secondary is the one that is outside. Okay, so they give you 5 characteristics and 5 reasons, which will give you the 10 marks. Okay, and that's it for question number 11. Okay, so last thing before we leave is the quote of the week. Okay, so if you can see in the screen behind me here, this quote is by this guy called Robert Kiyosaki. Okay, Robert Kiyosaki is the guy that wrote this book called Rich Dad Poor Dad lah. Okay, and he tells a story. Actually, he's not just telling a story; he's also sharing his life about how he got rich. Okay, it's a story about how to get rich, but not scheme cepat kaya lah. Okay, it's how to, what are the skills you need, what is the wisdom you need in order to get rich. And Robert Kiyosaki is the guy that wrote this lah, this book, Rich Dad Poor Dad. He says in his book that he had 2 dads lah. One is his real father, and one is the father, his financial father. As in, he taught, this financial father taught Robert Kiyosaki how to become rich. And because that financial father himself was rich lah. Okay, so Robert shares in his book, he shares the story about his 2 dads and how they are so different from one another, and he also shares his own success story, how he became rich. But the quote of the week, okay, the quote of the week says this lah. The size of your success is measured by the strength of your desire. The size of your success is measured by the strength of your desire. How badly do you want this? The size of your dream. Okay, and the most importantly, the one I marked in red, how you handle disappointments along the way. Okay, that is the size of your success. Okay, if you know every success story, nothing comes without any sacrifice and any disappointment. Okay, but one thing that you should remember, even as you are getting back all your trial results marks, right? Okay, never forget that it is not fatal. It is not the end, and it is a disappointment along the way to success. Okay, nobody who is successful has never encountered any disappointments. That's a lie lah. Okay, saya berjaya ini tanpa sebarang kekecewaan. That's a lie lah. Okay, don't be scammed by those kind of people. Every person who is successful, including myself, wow, okay, has been disappointed once or twice or many times in his or her lifetime. Okay, it is how you handle the disappointment that is the one that really determines whether you are going to be successful or not. All right, so with that, we shall end our classes for this week. I will see you all next week. Okay, take care, everyone. Bye.